Hi AppSec engineers, welcome to this episode of Way of the Future. Now Kubernetes has emerged as one of the most important aspects of infrastructure as code. Now just like any other code, infrastructure as code has also to be subjected to security tests, especially static analysis. So in the Kubernetes world, we subject our Kubernetes YAML manifest to some sort of security analysis through Kubernetes linters or to Kubernetes security scanning tools. In this video, I'm going to be looking at 4 different Kubernetes static analysis tools or linters and doing a smackdown between which one of them performs the best. Stay tuned for the rest of this video. It's going to be exciting stuff. If you like this sort of content, please like and subscribe to our YouTube channel. Please follow us on LinkedIn and Twitter, where we're going to be posting constantly useful content around cloud native security, Kubernetes security, DevSecOps, AppSec, and many more interesting topics. Kubernetes is all about YAML manifests. Now, YAML manifests are these source files that consist of configuration definitions for applications, services, ingress controllers, or any other resources that we want to deploy or we want to manage within Kubernetes. Now, these are the building blocks of what actually goes into our cluster, because all of these manifests essentially are deployed and managed by our Kubernetes cluster. So obviously, these are very important, and the security that we apply to these manifests is also very important. If we add security issues to these manifests, that could result in a massive security exception in our Kubernetes cluster. So it's very important for us to be able to identify security issues early in this particular cycle. So if you're able to identify security issues early, just at the manifest stage, you may be able to correct it and therefore may be able to prevent a massive security issue when your Kubernetes cluster gets deployed. Now, in this video, we're going to be looking at 4 tools that are going to help us identify security vulnerabilities with your YAML manifests in Kubernetes. The 4 tools we're going to be looking at are 1. Terrascan from Accurix, 2. KubeLinter from StackRox, Checkov from Bridgecrew, and finally KubeSec from ControlPlane.io. Now, all of these 4 tools have the ability to scan YAML manifests and are able to identify security issues based on a certain set of rules that they have configured to be able to point out security exceptions or potential security misconfigurations from your YAML manifests. Now, keep in mind, this is not a comprehensive security review of your Kubernetes cluster or anything like that. We're essentially doing what a static analysis scan would do against source code, and in some cases even lesser, because we are not able to peer into the container. We are not able to identify security issues with the underlying container and things like that. These essentially examine YAML manifests and look at potential security misconfigurations or areas of improvement that we can add to our cluster to make it more secure. That's going to be the focus. So please remember, there are some limitations in what we're doing. Now, in this, you will see that there are some common factors for at least some of these scanners. For instance, KubeLinter, Terrascan, and Checkov are all 3 tools that have commercial offerings. So their creators essentially have enterprise or commercial offerings that have more comprehensive Kubernetes or cloud scanning capabilities. With that, let's get started with our smackdown and analysis of these 4 tools and how they behave against my test YAML manifest that I've set up for this particular demo. Let's get started. All right, let's get started with our smackdown of the Kubernetes security linters, right? We're going to be looking at 4, like I said in my intro. We're going to be looking at Terrascan, we're going to be looking at Checkov, we're going to be looking at KubeSec, and we're going to be looking at KubeLinter as well, right? So we're going to be looking at all 4 of these, and then we're going to be exploring it against a single YAML manifest that I have, right? This is a very small manifest. As you can see, it just has one deployment of one app. This is not a huge manifest. It does not have a lot of nested resources and things like that. It's just got some basic information. It's just pulling down one container image. It's going to have, it's going to be running on port 5050. Of course, there is the obvious security issue here, which is the privileged flag is set to true. Now, obviously, what we want to see is test this particular YAML manifest of Kubernetes against multiple linters and see what they come up with. Look at their features, see what, compare their features in terms of what they can and what they can't do. So let's get started with that. So the first thing I'm going to do is run Terrascan, right? Now, Terrascan is essentially not just for Kubernetes, right? It is for things beyond Kubernetes as well, right? So it's for AWS configurations, and I think Terra, the very name Terrascan, is specifically more oriented towards Terraform, but they also, so Terrascan, as the name suggests, is for, I think, largely for Terraform, but they also do other things. So let's look at how Terrascan works, and let's run against our YAML manifest with Terrascan. So the first thing I'm going to do is run Terrascan. And Terrascan, you essentially need to use the scan command, and you need to specifically state that you're scanning a Kubernetes YAML manifest, right? And in this case, I'm going to reference it to a specific file, which is our Vulflask file, which is in testbed, Vulflask deploy, and let's see what this comes up with, right? So this comes up with a console log kind of a thing. You can see that CPU, all of these things are issues that Terrascan has identified with our Kubernetes manifest. Let's kind of dive into this a little bit and see what's happening here. So one of the things that struck me initially itself is that the line number that they've given here is not really, accurate against the issue that is being faced, right? All of it is set to line number 1. I know for a fact that obviously the privileged flag is not on line number 1, or a lot of the other things are not on line number 1, but everything is set to line number 1. Now, this is a little confusing because obviously, especially if I'm dealing with a huge manifest, so let's say I have a lot of resources in that manifest, this is not ideal as far as I'm concerned. But let's look at the actual results and see what it's found and what it's not found, right? So so a few things that it's been able to identify. Of course, CPU request not set in config, that's fine. AppArmor profile not set, so that's true. We have not used the AppArmor profile. However, you should be able to set it up with the Terrascan config whether you want it or not. There's no default seccomp profile, that's also not there. Container image with the latest tag, rollback and track. This is a good finding. This is not only security finding, but it's also a more reliability level finding, which it considers low severity, but it can be argued against. Containers should not be run with allowed privilege escalation. Now, this is actually, I don't know whether, now this is weird because I'm not sure whether it's pointing to the flag that privilege is set to true or whether this should not be running with allow privilege escalation. So this is kind of weird because there is a parameter in the security context called allow privilege escalation, and that can be set to true or false as well. So that's something that you should keep in mind. Minimize admission of root containers. Again, I think it's kind of inferred that this is root container because the must run as non-root security context has not been set. CPU limits have not been set. Memory limits have not been set. All of that is fine. So container images, the read-only file system set as false mounts, write permission. That's another issue as well. Security context has been applied. There is a security context, I think. Let's have a look. There is a security context, which is not ideal. Of course, the security context parameters are set horribly, but there is a security context. So this, I would say, is a false positive. Readiness probes, absolutely. Yeah, that's a valid point. So there are 562 policies. Again, a lot of these policies are not only Kubernetes, right? So they're going to have your AWS, your GCP, your Azure policies, but looks like we've violated about 16. Now, some of the good things, obviously, it tells you things that needs to be done, and it gives you some information about that. The bad thing is this line. This is a little irritating for me because I find that this line thing is not very accurate simply because everything is pointing to line number 1. It gets confusing, especially when you're dealing with a huge manifest. I wish the line setting would be better, but hey, it's open source. There's nothing we can do about that, I guess, except probably somebody submit a PR for that. But hey, that's how it works. This also has a JSON format. So the other thing with this is that it has JSON format. It has support for YAML and XML multiple formats, which is a good thing because you want to be able to consume this report, in some way, shape, or form. The other thing that you should think about is whether this is failing based on the scan, right? So it has some high severity results, whether it is failing. So let's look at the exit code of the scan, and it's exit code 3, which is a non-zero exit code, which means that if you run this in a CI/CD platform, it's going to throw non-zero, it's going to fail that build. So which is depends on how you look at it. It's a good thing, right? So it's largely a good thing because you have the ability to do that. The other thing is that it also, like I said, has the output format. So let's look at the output format real quick. I'm going to use a JSON output and see how it works. I think I need to reference it correctly. Test bed. And you look that it gives you a JSON response. Now, with a JSON response, again, it prints out on standard out. So I don't think it has some kind of a file output concept. It just prints out on standard out, and you can probably pipe it to a file. I think that's what you need to do. So you'll probably need to do something like terascan.json. That works because obviously it outputs to JSON. But the problem with this, I hope it's not a problem, but let's see. Oh, it still gives you the non-zero exit code, which is great. So even sometimes when you do this, when you pipe it to the output, I think in some cases it might take it as a zero exit code, but in this case, I think clearly it's taking it as a non-zero exit code, just piping the output, which is good. You can see that this has a little bit more detail. It has some information about rule ID, where you probably have some information. It is an internal reference that Accurix has for the rule ID, I think. And that's how they identify it. And of course, it has some scan summary and things like that. This is good. This is useful, definitely. But my only big peeve for me is the line parameter, which is all set to line 1, which is not super helpful. Now let's look at our other tool. Let's look at kubelinter from StackRox. Now kubelinter, again, is an open source project from StackRox. Let's actually cd into testbed and look at what kubelinter can do for us. Let's quickly run kubelinter and see how it works. Now kubelinter, as you can see, comes up with another bunch of std out console messages, and it does give you some problems identified. Now Terascan gives you, clearly it has, I'm not sure how many violations it has. It has 1, 2, 3, 4, 5, I think 16 or so, right? It violated 16. That's what we saw. It violated 16 rules. Now, if we look at kubelinter, it has violated a bunch of rules as well. I'm not sure whether it's 16. Gotta probably output it to a format that we can actually count it in 2, 3, 4, 5, 6, 7, 8, 9. So it clearly is, I think it's found less than what kubelinter has found. Of course, that's not the point. It's not just quantity. We also want to look at quality. So pod affinity has been identified here, which is kind of interesting. You don't necessarily need to have pod affinity or pod anti-affinity, but again, it depends upon how you're setting it up. Probably more a best practice rather than a security vulnerability that pops out straight out the bat. Does not have a read-only root file system. Fair enough, it does not. There is no read-only root file system set to true. It's privileged. This has found the actual privileged container, which is good. The previous one was a little, so Terascan was a little on the fence, right? Allow privilege escalation is set to, it spoke of that, but it didn't point to the fact that you are actually running it as a privileged and you're not running it as non-root. So all of those things is pretty useful. This is a little bit more minimalistic. The way I see it, it's focused more on, hey, you know what, this is what I found, rather than trying to be a little more opinionated about what it didn't have, other than a couple of findings here, which is the selector and the replicas and things like that, which is useful. Definitely, it found 9 lint errors. So I silly me, I didn't read that it found 9 lint errors, which is pretty useful. Again, now let's look at the exit code for this one. And the exit code, like I guessed, is 1, which means that if you run it in CI/CD, it's going to fail that build. So the exit code for this is set to 1, which means that it's great, because if you run it in CI/CD, it means it's going to fail that build, right? So this is something. Let's see if kubelinter has a output option. I didn't see an output option when I looked at kubelinter. Yeah, I don't think it does. Even within the lint command, I didn't see an output option. You probably, I don't have any details about the specific flags. Again, it's not super easy to identify from the CLI that what kind of flags they allow and things like that. But clearly that's the issue here. Verbose, I think, gives you some additional information. Let's use verbose and see what it gives you. I think it just gives you a little bit more remediation stuff, right? So I think it's pretty much the same in terms of verbosity that it has. It doesn't give you a parsable file format, which is a problem for me. I don't like that aspect of it. Although it did find some useful issues, it didn't give me a parsable file format. So it's more a, I think they probably have it as part of their commercial offering, but definitely in the open source one, I find it of limited utility if it does not. I'll probably have to sit and write something, or maybe I'll probably have to parse it in a different way, which is not something I'm terribly fond of doing. Now, we're done with kubelinter. Let's look at the other one, which is Checkov, right? So Checkov essentially is from Bridgecrew, and I have liked Bridgecrew for some of their previous work in this space. Terraform linting is something that they do pretty well as well. So let's look at running Bridgecrew's Checkov against this YAML manifest. Now, this is pretty simple. When you run it, it gives you a lot of different findings. It tells you, the good thing about this is it gives you line ranges, right? I like that. It's kind of nice because it gives you line ranges. It's failed 19 checks. So it's clearly found a lot more checks than, so it's tested about 27 check on more than that. I would say it's tested about 31 checks perhaps, and then it has failed 19 and it's passed 12. So that's clearly, so it's passed some of these things, which is good. It actually tells you what you've passed. I like that a lot. I like the fact that it tells you what you've passed and what things you have done, if you've done something, what you have done, which is good. Although this is a little bit of a false positive, right? Capsys admin Linux capability, do not use. Yes, I've not used it, but I've set privilege to true. So I should be essentially failed for this because privilege is set to true. It's not ideal. MHPL policy. Let's look at some of the actual findings though. Seccomp, it's found Seccomp, the Seccomp issue is there. It's obviously not running with the high UID. Of course, it's running with privileged container. Apply security context to pod and container. This is weird because it says apply security context passes, and then it says apply security context failed. Weird. I'm not sure why that is the case. Clearly, it's found both. Now, this is a great finding though, because I'm not disabled service account token mounting. This is useful. This is actually useful to me because I think no other scanner, at least the open source ones, didn't find this. This is a good one. It's also a little opinionated, which is nice. I like that it's opinionated. I like that it's actually making the choice and say, look, you need to probably don't mount the service account token. You don't need to mount the service account token unless absolutely necessary, which is good. Default namespace, we already saw that with Terrascan. We didn't see that with kubelinter, interestingly, right? None of root containers, this also Terrascan found. Capabilities, again, this is a little weird to me because I have a privilege set to true, but again, we don't have with capabilities assigned. This has found it, but it's a little confusing. Memory, liveness probe, these are all fine. Allow privilege escalation. Again, it's the same kind of thing that Terrascan did. Container should not be privileged. This is a good one because it's clearly pointing out that the fact that the container is set to privileged, and it's also giving you the line range, which is correct. Read-only file system, that's absolutely fine. Netraw, etc., etc. These are all great. These are fine to CPU limits and so on. So this is useful. Now Checkov, let's look at the exit code. Clearly it works in CI/CD because it will fail the build as we thought. Now let's look at what are the different options with Checkov. Does it produce parsable formats, right? I think it does, if I remember correctly, which is, yeah, output. So clearly you have the output. You can do a JSON. Let's actually try that out. Output with JSON, right? So it gives you a JSON file format, which is useful. And it gives you code blocks, which is also useful. This is nice, right? So this is nice. And if I pipe that to checkov.json, this clearly gives me the details that I need. And hopefully it should also not change the exit code. Yeah, same here. Exit code still remains 1, which is pretty good. So this works. I think Chekhov is amongst the three. I would choose Chekhov more than the other ones simply because of first the number of findings that it has. It gives me the positive findings. It also gives me the negative findings. Yes, there are some discrepancies, but again, these are not obviously going to be perfect because we are doing static analysis. Static analysis is not perfect. Now let's look at the final one, which is KubeSec. Now KubeSec has been around for a very long time. I've used KubeSec since I started doing Kubernetes security training. Now, initially it was great because it was the early one out there, but right now I think it's started to show its age a little bit, and I don't see it being as good as the others. The other downside of KubeSec is that it makes a request out to an external IP address or an external source, and then I think pulls down rules or checks it against those rules, which is something I don't particularly like. I think in the newer versions, they allow you to deploy your own server, your own KubeSec server and run it. But if you're just running it off the bat, it does make that external request, which I'm not particularly fond of. Now let's see what KubeSec does. Now KubeSec is ideally not great because as you can see, it's clearly saying selector is required, which is not very useful because it's not even parsing it. It's just saying, sorry, I'm not going to be able to just even scan this. If I even do something, I'm not sure whether there is a thing I can do. Doesn't seem to be much I can do it in terms of, let's see whether, yeah. So let's try and do this, right? Cat, val flask, KubeSec, scan. Yeah, same. Selector is required. It looks like the YAML file does not have a selector, so it does not even scan, which is not ideal. The other ones at least scan. And I know that the YAML file actually works in a Kubernetes cluster because it actually gets deployed, it gets scheduled into a Kubernetes cluster. So this works, but for some reason KubeSec does not. KubeSec, I would say, amongst the four, I think KubeSec has been a little disappointing because clearly it does not even parse it, or even if it parses it, it needs some kind of a prerequisite of the selector, which of course I can add in. It's not a big deal, but it's not ideal that it just fails right off the bat. I wish there was a force option or something like, or ignore errors option or something like that. That would have helped, but clearly it does not. So I would say Chekhov is my vote for the best one. Terrascan is pretty good too. KubeLinta, I would say, comes in 3, and KubeSec does not. I don't think features in this because KubeSec is kind of a little old school right now, and I think it's not as. I think it's not kept up to the kind of security scanning that is required of Kubernetes manifests as much as the other ones. This is not just from this particular example, but this is also from previous examples as well. So yeah, this is our smackdown of Kubernetes security linters. If you liked that video, you should consider liking and subscribing to our YouTube channel. Follow us on LinkedIn and Twitter. And if you want the best quality education for AppSec, cloud native security, Kubernetes, DevSecOps, threat modeling, and a constantly updated library of amazing courses with amazing hands-on labs, you should get a subscription for AppSecEngineer.com. Subscriptions are available for both individuals and teams of any size that you can access on AppSecEngineer.com. Please check us out.